This is the first section on the chapter 2 in the applied year 2 book, and this is on conditional probability. This first section is basically a recap of what you've learnt about Venn diagrams from GCSE. So we've got our Venn diagram, then the box is called a sample space. We use this funny curly E, you can put an S if you want to there. So that stands for the sample space. Everything is inside the sample space, all our numbers. All our values go in there. Our probabilities go in there. So remember that the intersect symbol stands for the overlap. So our intersect. The union represents everything that's inside both of the items. So this would be the union of A and B. And if it's not in something, like we call this the complement of A. So this diagram here is showing not A. And quite often in these questions we're either counting items in there or we're working out probabilities. So let's have a go at a question. So a card is selected at random from a pack of 52 playing cards. Let A be the event the card is an ace, and D the event that the card is a diamond. So I could represent this on a Venn diagram, I don't have to. And this type of question does require that you do know about playing cards. So they tend not to put these questions in exams because people don't really know. Not everybody knows about playing cards. So here we got an ace and a diamond. Okay, right, so we've got 52 cards altogether. I know that there, in a pack of 52 cards, there are 4 aces, there are 13 diamonds, and I know that there's one card that's the ace of diamonds. Right, so whenever we fill in a Venn diagram, we fill in the overlap first. So let's start with the ace of diamonds. There's one of those. There are 3 remaining aces, so that makes the 4 aces altogether. And there are 12 remaining diamonds, so that makes the 13 diamonds altogether. But remember, there are 52 cards, so a number needs to go out here. That's the cards which are left. So if I add together 3, 1 and 12, I get 16. And if I take, sorry, not 16, yeah, I do get 16, I'm disagreeing with myself. If I take 16 away from 52, I'm left with 36, so 36 is here. Yeah, so I didn't need to do a Venn diagram, but I'm going to use it to help me answer this question. So part A, this is basically, what's the probability that it's an ace and a diamond? Well, that's the overlap there, 1 out of the 52 cards. B, what's the probability that it's an ace or a diamond? That's the A union D, so that's anything that's inside A or D, so that's the 3 plus the 1 plus the 12, so 3 plus 1 plus 12 over 52. So that gives me 16 over 52. Part C, the probability that it's not in A. So anything that's not in A, remember that the 3 and the 1 are in A. So the stuff that's not in A is the 12 and the 36 out of 52. So that would give me 48 over 52. I can leave it like that. You can simplify it. You don't need to simplify probability answers unless the question asks you to. And part D, the probability that it's not an ace and it's a diamond. Now sometimes doing questions like this can be a bit tricky to visualize. So what I do is this. I use shading to help me answer. So this circle here is A, this circle here is D. I'm going to work out of 52 which number or numbers I need to be looking at. So the first thing I'm going to do is I'm going to shade everything that's not in A. so not A. Okay, so I'm going to shade all of that. So all of this stuff here is not A. Okay, done that. And in the opposite direction, I'm going to shade the stuff which is in D. So that's the second one. Actually, let's color code it. Let's do it in a different color. Let's do orange. So now I'm going to shade all the stuff that's in D. There we go, a little bit outside of D. There we go. And because I have this intersect symbol here, I am looking for the stuff where I've shaded in both directions. Now I've shaded in both directions just in this part of the Venn diagram. That's where I see 12. So 12 out of 36. Let's get it in black. 12, sorry, not 12 over 36, 12 over 52. So my technique to do a question like this is to shade. Now once I shade, if I have this symbol, the intersect symbol, what I'm looking for is shading in both directions. If I have this symbol, I'm looking for shading in any direction, whether it's this or this or this. So any type of shading, that will tell me which bit I'm looking for. So if instead this question said not a union D, then I would include anywhere in this diagram that I've shaded, which would be everywhere apart from the 3 here, yeah, and that would be 3 over 52. So after question, let's make up a part E. So if part E said, what's this? Probability of not A union D. Okay, so I've already shaded the diagram. I've shaded not A in one direction, I've shaded D in the other direction, and all of the shading I have is everything apart from the 3. So that'd be 52 minus the 3. So that gives me 49 out of 52 if that were the question. Okay, here's another one here. So we know about independence. If you don't know about independence, I'll just remind you. So if A, or events A and B, are independent, then the probability of A times the probability of B equals the probability of A intersect B, if they're independent. If they're not independent, then that statement won't be true. Now you would have done this in year 12. Okay, so in part A, if I want to explain why events A and B are not independent, well, let's work out what is, so the probability of A times the probability of B, well, that's 0.3 times 0.4. Now that's 0.12, not 1.2. And the probability of A intersect B is 0.25. So can you see they're not equal? Okay, so they're not independent. So you'd write something like, since this does not equal this, events A and B are not independent, which basically means one event affects the other. So if one thing happens, it's going to affect what happens with the other one. They're not completely independent. Right, and then this is given that probability C is 0.2. Events A and C are mutually exclusive. B and C are independent. Draw a Venn diagram. Right, okay. So let's draw our Venn diagram. Now it says that A and C are mutually exclusive, which means that A and C don't overlap, but A and B do overlap, so we're going to have to be careful about how we draw this. So A overlaps with B, A, B, and B overlaps with C, but C doesn't overlap with A, so maybe something like that will do. So here's my sample space there. Right, so whenever you do a Venn diagram, fill in the overlaps first. So I'm going to struggle to get the numbers in. So that overlap is 0.25. Now if the probability of A is 0.3, and I've already used up 0.25, this is 0.05. And before I fill in B, I need to work out this overlap. Now it says that B and C are independent, so I can just multiply together the probability of B and I can multiply that with the probability of C to get the overlap, because it tells us they're independent. So that's number 0.4 times 0.2 is going to be 0.08. So that's going to go in there. Right, now for B, I know that all of B is 0.4, but I've already used up 0.25 from one side. So I'm going to take away 0.25. I'm also going to take away the 0.08 from the other side, leaving me with 0.07. I'm just going to double check that, make sure I've worked out right. So B is 0.4 minus 0.25 minus 0.08, yeah, 0.07. Okay, and C is 0.2. I've used up the 0.08 where it overlaps with B, so I'll take that off. And I'm left with 0.12 in here. Now remember, the whole lot needs to add up to 1, so there may be a number that goes on the outside. So let's add up what we've got. 0.05 plus 0.25 plus 0.07 plus 0.08 plus 0.12, and that leaves me 0.57. So if I do 1 minus that, I should get 0.43 if I've done the maths correctly. Yeah, that was basically what's left over. So if I add all of these up, 0.05 plus 0.25 plus 0.07 plus 0.08 plus 0.12 plus 0.43, I should get 1. There we go. Right, so there's my Venn diagram. I've shown all of the probabilities. Last bit of the question, part C. Now we seem to have some sort of compound question going on here. Right, so it's just like BODMAS really. We need to work out, do the bit in the bracket first. So we want to find out what this is. The probability of A and not B. So we could use shading, but basically it means you want what's in A, but you want to slice off what's in B, and that's 0.05. So this is 0.05, okay, and we want the union of that with C, okay. Now actually I will go back and do shading on this. So let me shade what is A and not B. A and not B is this bit here, that's A and not B. And where does that overlap with C? Now that does, oh actually it's not overlap, it's what's in C as well. So I also want this. So basically I want to add those two bits together. So it's going to be 0.5, union is like plus 0.05 plus what's in C, and remember that is 0.2. So final answer 0.25. So the union symbol basically means what's in one and the other, so it's not the overlap, so 0.25 for that. So you're now in a position where you can do exercise 2A on pages 19 to 21.